Hey guys, welcome back to the shop. I'm going to begin machining the next piece for our Fireball hardtail vise, and that is going to be the tail housing right here, or the hardtail, in which is what gives the vise its name. This piece right here is going to bolt right to the back side of the main vise body here. So we have some milling and drilling to do on this end, and on the opposite end, the outboard end here, we've got some boring, counter boring, and also some facing to do there as well to square everything up. So the tail housing here, or the hardtail, this counterboard in here is where the nut for the vise goes. So this is the actual nut. The threaded end is down here about 4 inches of this section, and this end has got the flange, and it simply slides through the hardtail here, sits into that counterbore. There's a couple holes that's drilled and tapped, and it gets bolted in using those 2 bolts right there. So the hardtail is what helps give the vise its strength. Jason's got this designed so that whenever you're pulling on the wrench and you're tightening up the vise, everything is being squeezed together, so the pressure is being pushed against this end of the tail housing, which is transferred through it to this face right there, creating a really nice, strong vise, which he's proved in his videos, and lately he's been doing some brand new torture testing over on his channel, so you ought to check that out. But we're going to focus on this guy today right here. I have been working on the CAD and CAM for this guy, and we're going to use our Miltronic CNC mill to mill this. We'll have 2 ops, 1 for each end, and I'm ready to get started on it. So this is going to be another tricky project that I hope that we can pull off without having any kind of errors or you know, incorrect offsets or anything like that when we're doing it. So I'll show you my setup. I've still got to finish getting everything trammed in. I've got to remove some of the tools out of the machine, and I'll show you briefly. We'll talk about that, what we got to do, but let's go ahead and start getting this guy set up. I've just about got our setup ready to go. We still got to get this trammed in, but this is what I've landed on in order to be able to hold our workpiece to get the machining done. So this is just one of my big angle plates. We do have it setting on some blocks here. So this is 3-inch risers. We've got our, I'm sorry, this is 4-inch right here. We've got a couple of 1, 2, 3 blocks in the back, and we've got that on both sides there. And then we're holding it down with a couple of toe clamps there through the slots. That should provide enough clamping force to hold that guy in place. I've already previously modified this with a couple 5/8 holes so that you can use some studs and clamp things to it. And lucky enough, it actually worked out perfect. So this is one of the clamp bars that I made a long time ago to use on the V blocks. I ended up making that center spacing 8-inch, the same on this V block there. So we should be able to stand the housing up right here and be able to pull it directly against this angle plate, and that should provide enough stability in order to hold that for our machining. I hope anyways. I mean, I am a little nervous about this, but I think it's going to work out pretty good. So the other factor that I have working against me right here that I'm trying to walk myself through now on making sure that we do this correctly is the tools that are hanging out on the tool changer. I have already moved this around, but I'll show you. We'll go ahead and jog the table a little bit. Depends on where this guy is going to go, but I'm going to move it back there against that tool as an example. And you can see how close it's getting to that tap. And we're going to be over here doing some face milling. So I know this is going to go up underneath here further than that. So this is proven to be another challenge that I'm having to tackle. And I believe what I'm going to do, just to play it safe, is go ahead and remove all of these tools. Just get them out of the way so that we don't have anything hanging down. And each one that I pull out, I'm just going to label it for which tool pocket it's in. And just, you know, we'll put it out here and get it out of the way, because as we move the carousel around to get more tools, more of these longer tools are going to be coming over here. So I'm thinking just remove all of them and just eliminate that challenge and possibility of crashing into a tool and breaking something. So I'm going to start working on that, and I'm going to get this trammed in. I'd like to show you guys the program briefly. We'll do a simulation so you can see what it's going to look like, the operations that we're going to be going through. All right, so I wanted to show you the program here and the modeling. So I worked with Kevin again for a couple of hours on this project. Thank you, Kevin, for always be willing to help me with these projects. You know, he's mentioned, he goes, man, you're jumping into some fairly complicated stuff. Not that machining these parts is that complicated, but you know, typically when you're new at CAD and CAM, you kind of start with basic parts, you know, a block of aluminum or steel that you cut off in the bandsaw, and you go to a mill vise and you do some milling and drilling and stuff like that. We're taking castings that we have one part of and having to design it, kind of backward engineer it, and then, you know, do our CAD off of a casting here on the bench. So he pointed out that it is a little bit more of an, you know, elevated part of your education. We're kind of jumping ahead of ourselves, really, is what we're doing. But anyway, he's been really helpful with this, and I really appreciate that. And I couldn't have done this without him, because there's a lot of stuff that you have to know and realize when you're using Fusion or any CAD software in order to get these guys designed and drawn and proven out the way you want. Okay, so we got setup 1 and 2. Right now, let's focus on setup 1. We're going to be working on what I would say the smaller end first, the very end where the nut's going to slide through. That's the side that we're going to work on first. And by the way, we actually modeled this twice. So what we have is we have our stock and our finished part. So stock would indicate the part as it's cast right now. And then the finished part is going to be our finished sizes on there. And that was helpful to during our designing to have both of those models on there. So that's what we're looking at. All right. And then we'll flip it over. This is going to be Op.2. This is the flange side right there. The only thing that we don't have modeled in here is there's a couple of scallops in these corners right there. We just didn't bother putting them in there because it really didn't need it. All right. We'll flip this back around. And I'm going to show you guys, we'll go ahead and do a simulation on setup 1. Now I'm going to continue to kind of optimize this. There's quite a bit of facing that's got to be done. And the reason why is because I don't want to come in there and be too aggressive on this cut right off the bat and then have problems, the thing vibrating, shifting, something moving, because we're being too aggressive with our face mill. So I am taking relatively shallow cuts on here. And it's going to do that, and I believe it's going to take it down 150 thousandths, I believe, something like that, to get it down to flat all the way across, because the casting does have a crown there in the middle of it, so it kind of raises up and goes back down. So we need to make sure that we clean the whole face up, and of course the counter bore and the bore is going to be in relation to that face once we get that done. So we'll go ahead and hit our simulation, and we'll run through here, and I'll speed this up so you guys can see. We're going to be doing a parallel facing toolpath there, keeping the cut direction the same each time. And like I said, the way I got it right now, it's going to be taking quite a few passes across there. It says it's going to take 7 minutes for this, but we were only doing one part, so I'm not really concerned about how long it's going to take to do it. And I'll definitely speed it up for you guys once we're showing the machining. All right, so let's back up a little bit right here. Kind of missed that. Let me see if I can go back. So this is going to be the end mill is going to come down and do a counter bore to clean that bore up. And then it's going to, I'm sorry, the bore is what I should have said. Now it's working on the counter bore. So it'll finish out the bore to size, and then it'll move up, and we're going to do the circular pattern here. 2D pocket is what we use for that, to clean this guy up. And then once that's finished, we're going to have to drill a couple of holes. This will be for 5/16 18. Drill it, tap it, and then we have a 2D contour for the chamfer and the lower chamfer there. And believe me, I'm going to be double checking our chamfer depth and make sure that we're not going to be cutting it too deep like we did on our last part. All right, so that's going to be Op.1 or setup 1, and we'll go ahead and flip this guy around. We made an Op.2 home view, so when we flip it upside down, we can kind of see it. All right, so we'll come down here to setup 2 and go ahead and generate that, and go ahead and walk through this one as well. So this is the one that I may be coming in here and tweaking on just a little bit more, because we still have approximately 300 thousandths to take off of this flange face once we do the first side. And that's just to get it to the print dimensions, which is 15 inches long end to end. And as it's cast, it's almost 15.5 inches. And that's from the crown to the crown on the other side. So we've got quite a few of these passes that it's going to be making across there. So we'll go ahead and kind of get through that. I know it's pretty lengthy, but we'll see what we can do to kind of optimize that a little bit better. It says it's going to take almost 9 minutes to get this done. There's your finish pass indicating the green. Speed that back up just a little bit. And then once it's through facing, we're going to come in with that same 3/4 end mill. So you actually have a lot more material on this end and this end that needs to be come off. So how we did that, we did a 2D contour on this side, and then we jumped over to this side. Once it roughs it, it'll finish it. It'll go all the way around to make one finished pass, because there's only about 15 thousandths per side on the other two sides there. So we'll show that. So I think it's going to make two passes, kind of like roughing passes. All right, and then we're going to make a finished pass all the way around to clean that outside up using a 2D contour. And then we got 4 holes to drill. Those would be clearance holes for 5/16. And then the last step is going to be the chamfer to clean the outside up, and then the 4 holes. The inside is cast, so I'm going to do that with a file and just do that by hand. So there's our program. I'm going to continue to play with it just a little bit and see if I need to make any changes to this before we actually get going. But I did want to show you this. This is what it's going to look like when we get our when we start our machining. All right, so I'm getting all the tools out of there, and I'm just creating a label and label them for the tools that they are. So this is something that I'm having to kind of learn the processes and proper management of tools, because always running manual machines, I never had tools like this set up ready to go. And obviously you've only got 18 pockets up here, and you're going to want to have more tools than that. But anyway, the fact that I'm actually taking them out of the machine, I need to know which pocket to go back into. So this is what I come up with. Maybe you guys do this, I don't know, but I'm trying to figure this stuff out. All right, so we want to do, this one's going to be, I'm just looking up here, active tool is 14. So I'm just creating these labels right here. Let's see. Sure does seem to waste a lot. Like he always wants me to cut this off. Maybe I don't have a setting correctly. All right, so there we go. Tool number 14. And I'm just going to continue to do that with all of our tools that we got in there. And what I've decided to do is just go ahead and the tools that we're going to be using in our program, I'm going to label those guys. We'll start like tool 20 and go up from there and have those labeled as well, so I'll know which tool. And so instead of putting the tools away in the carousel, we're going to use one tool. I'm going to remove it, install the next tool for the next operation, so I don't have to worry about these guys over here in the way while this table is moving around with the workpiece. Okay, so I got all the tools removed from the machine. We've got them all labeled, so I know exactly what tool pocket to put them back into. And we're going to be stealing a couple of the ones that we've already got set for our tools that we're going to use for this tail housing job that we're going to do. So let me give you a rundown. This is the tools that I'm getting ready to set up. We'll start with this Walter face mill. This uses those triangular shaped inserts, the TNMU inserts. And this will be the first time using this, but it's 2.5 inch diameter, and it's going to be a good width for doing both sides of the tail housing there that we got a machine. So we'll get that. We'll use that for our face mill. This guy we're going to use, this is a Walter 4-flute carbide end mill with a 30 thou corner radius, and I wanted to use this guy when we're going in and doing our counter bore. I wanted to have a radius in that corner there, so we'll get this guy installed in our Heimer shrink fit holder. ER25 collet. Now I'm going to be running a letter F drill. This is a high-speed steel, and I can use this, but I've actually got a solid carbide drill in order, and I'm hoping with any luck it may actually be here tomorrow. I wasn't planning on running this today. We're just going to get everything set up and ready to go. So if the solid carbide drill shows up tomorrow, I'm going to modify my program, and I'm going to add another tool for a spot. I'm sorry, if I use the high speed, I'm going to add this spot drill so we can go in there and spot them. This is a 1/4 inch diameter, just spot face drill. This is a melon, and we'll add this if we use our high speed. If the carbide does not show up, we're going to run this. If the carbide shows up, we won't use that. We'll use the carbide drill. ER16 collet, I'm going to install this Cleveland 5/16 gun tap in there for our tapping, and then we're going to continue to use tool 6. This is a 3/8 diameter mill drill, and I mainly use this for spotting and for our chamfers as well. The holes that we've got to drill and tap are really close to the sidewall, so I don't think that this 3/8 may fit in there, so that's why I said I'm going to probably install a 1/4 inch diameter and use that if we need to spot it. All right, so we'll just continue using this one as tool 6, but my thought process is we're going to probably start with, say, tool number 20, and we'll label it 20, 21, 22, 23, and we'll continue that as tool 6 and just manually install it whenever it's ready to run that part of the program. So I'm going to get all these guys set up. We've got to get them installed, get them touched off. I'm going to be working on that right now. Okay, we just got our face mill touched off. So we'll go down the line. Next up, we'll get our 3/4 inch end mill installed and get it touched off on the Renishaw tool setter. So on our tool holder, I went ahead and adjusted that backstop down in there so that when we drop the cutter in there, I don't have to hold it. We can just let it go. I just did a measurement on the shank right here and just used a scale and just measured it where we wanted. So this guy is E5 on the holder, ultra short. That's calling out for disc number 11 to use. We'll take this one out and find our disc number 11, which is going to be this guy. Some of these, for these shorter holders, have an extension right here, so that one should be the proper disc. Yeah, it's got to come down and touch the face of the holder. All right, safety shades engaged. Here we go. I don't know how long this is going to take. I'll tell you when we start it. 7 seconds. All right, let's go ahead and get it over here on our coolant sleeve. Just like that. Been on there for a minute. Yep, good to the touch right there. Still slightly warm. I'm going to go ahead and let it go for about another 30 seconds. All right, it's good and cool. Let's get that tool set. All right, that's going to be our length. Okay, we need to go to the side. I'm going to use the Y-axis because its spindle's really close to this angle plate. Okay, that should be good. The spindle is running in reverse, by the way. Okay, great. That tool is set. Okay, I've got all of my tools set for this program that we're going to run. We got our face mill, end mill, spot drill, tap, and a chamfer tool there, ready to go. Okay, so during this process, I had contacted my buddy John Saunders and was asking him about, I said, hey, is this a dumb idea putting these labels on there? He said, it's not dumb at all, but the couple things that you got to keep in mind. First of all, these labels are probably not going to hold it very well, and I realized that going into this. I was looking at this as just a temporary thing, but he brought up a couple points. He says most likely these are not going to hold, they're going to fling off. The other thing that it might risk is causing an imbalance in some of these tools, and if you're running super high speeds, I can definitely see where that would come into play. If you're running these end mills super fast, that it could cause a little bit of an imbalance. The labels, we're going to be running, I don't know, about 1,200 RPM on this. This one's around 1,000, and then our tap will probably be around 250 or so. And then now this is going to spin up pretty fast, our chamfer tool. So we'll just see how it goes. But I wanted to just point out, so this is something that I'm continuing to have to learn, and I'm kind of looking for pointers from you experienced guys on how you manage your tools, how you label them, and keep them labeled when they're being stored out of the machine to know exactly what tool is in there. So this was the very first step in this process of me learning, and I think it'll help me out just as a temporary basis so that when we're done with this job, I can go ahead and put all these tools back in the proper pocket, and then I can just, when I do that, I'll just go ahead and pull those labels back off there. All right, so I'm gonna go work on the program. I got some tweaking to do. I'm gonna add a spot drill in there and just kind of get ready in case I'm and decide to go ahead and just start running this program and not worry about the solid carbide drill. Gonna finish getting this angle plate trimmed in now. Off quite a bit. All I did was just stick it in there and eyeball it straight. So just got the toe clamps just snugged up a little bit. Using a wide button tip on the indicator, so it'll sweep across that notch. It's going to be close right there. Let's see. All right, so let's go ahead and adjust our indicator to a 0 right there. That's about a 1/2 thou pass. That'll be okay. About 2/1000. That's looking pretty good. Okay, that's about a 1/2 thou right there. See what we are on the other side. And that's about a 1/2 thou right there. So that's nice and trimmed. And I'll come in here with our socket wrench and make sure that we're tightened up properly. Yeah, because I'm gonna have to move this guy where I can't really see it that well. It's too far back there. Let's go ahead and get him snugged up though. That's good. That's within a 1/2 thousandth from end to end anyway. So for just a little extra holding power, I went ahead and added a couple of those Lenski's right height clamps there, one on each side. We've got the brass shim underneath the pad there so we don't mar up the fixture plate. So we got 4 locations there now where it's holding the angle. Now we've got these 5/8 studs that we just put in here. Screw those in. This is the blind holes, so screw those in until they stop. I had thought about modifying this and bringing it up a little bit higher, but I overruled that, thinking maybe it's a little bit unnecessary to have to do that. And then we take our square block right here that I made so long ago and used on a horizontal board mill for probably hundreds of jobs. And then I'll put a nice big heavy duty washer on that. Where did it go? That's the wrong one. Heavy duty washer, and we've got our 5/8 flange nuts. And that'll be the setup anyway, right there. Make sure that it's pulling nice and even. It's a little bit of bow in the middle, so it's only going to be pushed on each side, which is okay. The other thing I need to do is just make sure that this casting is nice and straight up and down. So I'm going to take some measures to be sure that we are up and down as close as we can, and then we'll tighten this guy up. And I decided that we're going to go ahead and center on the outside of the casting right here. This center hole seems to be shifted to one side approximately 100 thousandths, but there's quite a bit of material in here that's going to be machined out, so it'll clean up the holes regardless. I'd rather this hole be centered on the casting from the outside so it visually looks like it lines up like it's supposed to, than it being shifted off to one side. All right, and I got an idea for alignment for the other side that we're going to work on later. But let's carry on. I'm going to finish getting this set up, and we got to find our work location next. I'm working on trying to get this side about as straight up down as I can. So I thought I'd show you. We've got the indicator, and I've got this amount of area that we can indicate, which I think is going to be good enough. And I'm going to use this little setup wedge here underneath this corner because it's going to need to go that way. So we're just going to tap that wedge to kind of make it go that way. I've got this C-clamp just kind of lightly holding it in place. And once we get it where we want it, then I'll put the other clamp bar back on here, and I think that'll work pretty good. So we got it in Z. I'll show you what we're working with. I've got it kind of zeroed out about right here because as you go all the way to the end, this tapers off smaller. So our size is more consistent from about this point down. And it's going to drop. That's about as far as I can go without hitting the spindle there, so I'm just trying to be really careful. So let's bring it back up. It's about right there. I'm going to go ahead and start tapping this wedge and see if that that's doing anything there. I think all I was doing was kind of shoving it that way, so let's try something different here. So we got a section about 6 inches of travel that seems to be pretty consistent on that 50 mark on the dial. So I'm pretty happy with that. All I did was just kind of tap this around a little bit, move the clamp, and I've got it kind of aligned the way I want. So for our casting, I think that's going to be more than adequate right there. Okay, we got our part clamped there nice and tight. I feel like this is going to be an adequate setup. I sure hope it will be. And we got our Renishaw. So this, I'm going to just touch off on what looks like the highest area for our Z. That'll be our Z0. And then we'll find the center of it this way there as well, an X and Y. Whenever we end up flipping this part over to the other side, this surface that we machine is going to be our 0 off of our Z there. We won't be touching off on the casting on that other side. So we're ready to go, single surface Z, and we are ready to run this one. Okay, that's good. Now what we'll do is I'm just going to kind of find the middle of it right here, and we'll go ahead and do our Y position. And on X, I don't think I want to use the center crown. We're probably going to move off a little bit. Looks like it's a little more even off of the center line there. Okay, that worked out good. Now we got to do the same thing for X. Okay, that worked out good, but I'm going to run it again. I'm actually going to bring the probe down just a little bit further. It was too close to that radius, so I'll just repeat that and make sure that we got down a little bit further there. I think I'm ready to start this first operation with our facing tool. I was having problems, and this was another thing I was trying to figure out with the machine, but what was happening was when I started the program, the tool itself, the spindle, was dropping down below our work surface there to a negative value, and then it was coming back up to the Z. And what I figured out is that that was actually in the machine coordinates, save tool position location. So I changed that to a 0 so that whenever any of these operations are going to start, the spindle will actually go all the way up to the 0 position and not have to worry about crashing into our workpiece there. So I've already proven it out once with air, and now we're going to go for it. Keep in mind, these are going to be relatively light cuts. It's probably not even be cutting very much on the very first pass here, but I just want to get this done. I'm not looking for a heavy chip load and how fast we can get it done. We just got one part to cut. So let's get rolling on this. Yeah, I think we got a lot of air on this cut here. It's just going to be hitting the center of that casting, right where the crown is. Should have something here. Not much though. Doubt it's going to cut anything on this pass either. Another air cut. All right, so I'm gonna have to come back across that and gotta make adjustment on my height there, because you can see we didn't quite clean it up. I was a little worried about that, but I was trying to be conservative there. Looks like I should have taken another 50 thousandths, so that's probably what I'll do, is just reset this and we'll take another 50 thousandths off that top. Cutter's doing good though. We've got a nice smooth finish. It really feels nice. So I made a 50 thou adjustment on our machine, and we'll go ahead and cut that again and see if that's going to clean it up. I'm going to bring this in kind of slow, just to let me get it down to the position where it's going to cut at. I just want to make sure that we're not digging in. It looks like it's going to be pretty good right there. All right, there's our cleanup cut on our face. And we can go ahead and load our next tool, and we'll come in here We'll machine the bore and then the counter bore. All right, on to the next operation. I did an air cut and I didn't feel confident where the tool was actually positioned. I think by probing off the outside, we're not getting an accurate center there. I've done a bunch more measuring on all 4 of these sides there, and I'm only getting about 20 thousandths difference. So instead of going off this outside, since it kind of drops off and everything, I think I am going to rely on where they positioned that bore, and we're just going to work off of that, because I was off center to this side and this side over there whenever I was trying our air cut. So I'm just going to reprobe it in our bore cycle. I've made an edit to our program, and we went back in there for Op.1, which is this side right here, and ended up, what the problem was is that the origin point was actually not in the center of this end of the box here. It was actually in the center on the bottom side that we haven't machined yet. So we had to adjust our origin point to a selected point, which is actually, I selected the center of this bore right here. So I've run through there once with air. We're going to do it again here so you can see what we're talking about. Now we're in a good position. I've got our coordinates set high. I'm going to speed it up. So it's look good. It looks good now. It should be in the middle of the bore. That's going to be the bore, and then it'll come back down and do a counter bore to clean that up to a 3 1/16 diameter. Now this is 200%, by the way. I'm not going to machine it this fast. So it looks good to me. I think we got a solid plan now, and we'll go ahead and make adjustments on our coordinates and see if we can make this cut happen. Wish me luck. Well, I am really happy with the results of that. I was a little nervous that it was gonna just do something a little funky or crazy. But man, it did a good job, and so did that end mill. Did an absolute beautiful job on that bore and counter bore. All right, I think the rest of them, I'm gonna feel a little bit better about the rest of the ops there, because that was gonna be the heaviest cut that we were taking. But I'm gonna get in and just do some measurements and make sure that we're on our diameters that we want. And then from there, if everything's good from there, we'll go ahead. So next up, we're gonna have a spot drill, a tap drill, and then a rigid tap. And then the last thing will be a chamfer. This is gonna be our 1/4 inch spot drill. Okay, I think that went pretty good too. All right, next up, we're going to be rigid tapping. All right, I'm going to make a little test run with this, just like we've been doing. And I like using anchor lube whenever we're doing our tapping with cast iron. So before we start the first hole, I'll brush a little anchor lube on, let it tap, and when we go over to wrap it to our next hole, I'll just pause the movement, turn the spindle off, re-lube it with our anchor lube, and then continue on with the tap cycle. All right, there's our anchor lube that we're going to be using on our tap. All right, let's see if we can make this happen. I'm a little nervous, but here we go. All right, I'm going to set the rapid to, all right, 0. All I want to do, I'm just going to stop spindle right there. Program is still running. And all I'd like to do, you know what? Don't worry about those chips. Let's just put a little bit more. Let's just dab a little bit more anchor lube on here. That is just going to assure that you're going to get a good cut in the cast iron every time. You're not going to have any galling or anything like that. All right, spindle back on. And here we go. Beautiful. Absolutely beautiful. Okay. Now, as far as the deburring the holes, I wasn't confident on getting in there with our chamfering tool to do the holes, so we're only going to be chamfering this edge here and this edge down there. All right, I think that's going to work. All right, guys, that looks good. This side of the hardtail is finished up. We'll just use our little Noga deburr tool here to just put a little deburr chamfer on these tapped holes. Well, I am very happy with the results of Op.1 right here on this end. We'd had no crashes, we didn't break a tool, everything went well, we're on size, the finishes look good, and what more can I say other than we've got a successful program right here. So now we're going to move on. I'm going to go ahead and break this setup down. We got to rotate it 180 degrees and get this thing on center. It's going to take a little time to get it set up, get it indicated, make sure we get it probed right. And I'm just going to do some of that off camera behind the scenes and get it done so you guys can kind of just see the machine work there. So basically the same thing. So we're going to face it, mill the outside perimeter, and then drill the 4 holes in there, and then we have an outside chamfer to do there as well. So when we get it ready to machine, we'll bring you guys back and we'll see if we can get the hardtail finished out.